Thanks InsureTech for this wonderful opportunity to present me and the insights which I have over my journey in data science. Thank you so much for this opportunity to present the information which I have. Right. So in this free webinar, free data science webinar by InsureTech Skill, I welcome you all. And as per my introduction, I'm working as a trainer and I'm working as a consultant with InsureTech Skills here. We do lots of projects, lots of training related to data science and analytics in collaboration with InsureTech Skills, right? So this webinar, the agenda of this webinar is to give you brief insights about what is data science, what is machine learning, what are the tools and technologies we require, we need to learn to upskill to switch our career into data science. And as per my information, this webinar will be seen by a lot of people who wants to switch their career into data science from some non-technical background, or some people who wants to upskill their career into data science and artificial intelligence. So I have tried to curate the topics accordingly, right? So which should be easy to understand for everybody, right? So let's understand from the complete scratch, what is data science, right? So as the word suggests, data science is a process of extracting insights from data using some statistical methods, machine learning, and programming, right? Just for an example, when we go to shop on e-commerce websites like Amazon or any other website, we must have observed that we see the advertisements like frequently bought together or highly recommended products. Whenever we go to watch any movies or any TV show on Netflix, right? They always recommend us some movie shows or some TV shows based on our past data, like what kind of movies we have watched in the past. They suggest us, they recommend us similar movies and similar TV shows to watch next, right? How does that happen? They gather our data, they analyze that data, and by using some statistical or machine learning models or some algorithms, they predict. Then they recommend us that, okay, you should watch this next, right? So everywhere there is a huge application of data science. For example, when you go on Instagram, we scroll reels. You must have observed we scroll with the type of reels which we scroll, we see more and more of a similar type of reels in our feed. How does that happen? Just another application of data science, right? So wherever you go, whatever you see, there is some or the other application of data science, right? So there are some key points which we should note, which we should understand about data science, right? It is used to make data-driven decisions, right? What happens in the past, the people companies actually used to take their decisions based on their emotional intelligence, based on their some discussions, group discussions, and all other things by human intelligence. But what is happening now with the evolution of internet, as common people are generating lots and lots of data every second. Trust me on this, every single click of ours on the mobile phone or on laptop generates some kind of data, right? And when companies understood that we have gathered sufficient data, lots and lots of data is being generated every day, they started to analyze that data. Then they started to use some statistical and machine learning methods to predict, try to predict the future. Just for an example, inventory management, right? Every year, like during December or January, just because of New Year, just because of Christmas, the sales go up, right? So companies have to manage their inventory. How do they do so? Just by analyzing the past data and creating some machine learning models to manage their inventory work, right? So data science is used to make data-driven decisions. It involves statistical, programming, and business domain knowledge. Many times people, what is a common error, what is a common challenge is that people only think that data science is only about coding, but it is not so. It also requires high understanding about the domain you are working in, whether it is healthcare, marketing, or whatever kind of domain you are working in. You need to have very good sense of the business domain, right? Then it also helps and improve customer experiences and operations. So for an example, nowadays, whatever websites we use, we can observe lots of application of customer care. They are AI-based customer care models. Why? Because it saves time. Lots of human errors are ignored just because of using AI in all of these domains, right? So I hope everybody understands what is data science in brief. Like, is there any question? you can raise your hand or just ping us. We can cover that question. Right now, so now we understand that, okay, this is what is data science, but how does the project flows in data science, right? So there are a few steps, like I have curated them into 7 steps. People might say 6 or 8, something like that. But in general, there are 7 major steps while we work on any data science project or any data science application. The very first and the step which I feel that we should invest the maximum time is problem understanding. Like I have seen a lot of people, they listen to the requirement, they attend a meeting, they read an email, and they directly jump to solve the problem. It is not like that. Until unless we are completely aware about the problem we are solving, we will always be distracted. So problem understanding is the first step which we need to understand, which we need to perform in any data science project. Second, data collection. We need to gather lots and lots of relevant data. Very important, relevant data from different sources. Data can be structured, data can be unstructured, data can be present in CSV files, Excel files, data can be present on cloud, SQL databases, or any other data sources. So we need to gather the data from different data sources, perform ETL operations, and get the correct data so on which we can do the further analysis. Correct? That comes under the part of data cleaning and preparation, like to make data consistent, handling duplicate values, missing values, and everything. Correct? After that, we have to do exploratory data analysis, in which we need to find the patterns, relationships in the data. We need to explore the data, dig deep into the data so that we can analyze all the aspects of the data. Actually, it should be a 360-degree analysis, right? From exploratory data analysis, we can find lots of trends and patterns over the data, from the data. For example, is the sales increasing month on month, quarter on quarter, year on year, or decreasing? Then if we understand this, then we will be able to create a model, and then we will be able to predict the future, whether it's descriptive analytics, predictive analytics, or whatever. After EDA, we have to build the model. Now, in building the model, we can have a lots of machine learning algorithms, like ensemble techniques, linear regression, logistic regressions, support vector machines. There are lots and lots of algorithms, but we need to choose an algorithm which should be good with the domain understanding, which should be good with the data we have in our system, and which has maximum accuracy, least error. After building the model, we have to evaluate the model. Like just for an example, what is machine learning? Just for an example, okay, I'll tell you. Let's say a student is going to the school. Teacher trains the student. So that is training, model building. The student is building the concepts. After that, examination happens. At that time, the knowledge which the student has taken is evaluated. In a very similar manner, we have the data, we have a machine learning model. We train the data to the model, and then after that, we try to evaluate the model, whether it is performing correct or not. And then we give real data, real-time data to the model so that it can predict the future, so that it can predict the correct output, right? As close as correct output. And then at the end, after building the model, after getting the final working model, we need to deploy it, we need to monitor, and we need to maintain the model. We need to deploy it either on the cloud or somewhere so that everybody can use the model, right? So I hope we are able to understand the workflow of data science, right? Just by a diagram looks at business understanding, data mining, data cleaning, exploration, feature engineering, predictive modeling, and data visualization, right? Okay, so I'll tell you one thing. These are just some fancy words. For example, feature engineering. What does that mean? I'll just tell you in a very simple example. Feature engineering is nothing but to select all the important features from a large database. For example, let's say we have 500 columns, but every column does not have equal importance. Let's say I need to select only top 100 columns, which are most useful, which are most contributing to the output. So I will do some feature engineering. I will come to those 100 columns and select them. Right? Data exploration, data cleaning, data mining, predictive modeling. Predictive modeling is nothing but to create machine learning models which can predict something for us. Right? So this is all. This all contributes to data science lifecycle. right? Now, whatever we have discussed so far needs to be performed using some tools. Obviously, I cannot do it through my mind, right? So we need to learn some common tools for data science, right? Whether you want to upskill yourself or you want to transition into data science, we need to have some basic and very advanced understanding of these few tools. Like for example, in programming language, we must know Python, right? Python or R has very similar application, but Python has a more acceptance in the market globally. So I always emphasize to learn Python before R, right? Once we are good with Python, you can, if you have spare time, you can definitely check R. R is very good as per statistics perspective, correct? After that, programming language, we must know data manipulation libraries of Python like pandas, numpy. Then we should have understanding about data visualization libraries like matplotlib, seaborn. Tableau and Power BI are different data visualization tools, but all of these in common perform data visualization. Means you have raw data in front of yourself and you are trying to convert that raw data into meaningful charts, graphs, and a complete dashboard, right? After that, we should switch on machine learning libraries. But before switching to machine learning libraries, trust me, get good hands-on. We should get our hands dirty with Python, pandas, numpy, and matplotlib and seaborn. If we really want to upskill, if we really want to excel in data science, then machine learning libraries like scikit-learn, TensorFlow, PyTorch, and so on, right? So scikit-learn is one of the most popular machine learning libraries. It has all the algorithms in itself, which we can just use to train our model, right? Now, if there is anybody who is very new to this industry, must be wondering what is library. Okay, so library is nothing but an extension of Python. It's kind of like a place where they have what should I say? They have created a lots of functions, lots of functionalities, which as a common user, as a developer, we just have to use those for our purpose. Instead of writing every code from scratch to the advanced, we can just use those libraries and perform our specific task, correct? And that should be more than sufficient for you to begin your journey as a data scientist or as a machine learning engineer. After that, if the time permits and if you have more interest, you should go for big data tools like Apache, Spark, Hadoop, and so on. Then we must explore cloud platforms like GCP, AWS, or Azure, and all of those things, right? So I hope we are able to understand the glimpse about the commonly used tools for data science, right? So if anybody has any question, just let me know. Moving forward, what are the important? Okay, so see, Python is very vast. Python has lots of applications, and nobody can be expert in Python just in some days or something. But there are the few topics which are very important to start your journey in data science from Python. Correct? So in Python, Python basics should be very clear. We should have a very strong hold on Python basics. For example, variables, data types, operators in Python, conditional statements, loops like for and while loop, functions in Python, user-defined functions and inbuilt functions in Python, list comprehension. In data types, we should study about integer, float, string. These are all the primitive data types. Then we have non-primitive data types, or you can call it collection data types like list, tuple, sets, and dictionaries. What are the applications? When do we use list? When do we use tuple? Why can't I use dictionary in this case? Why can't I use tuple in this particular case? So you should, all of these basic concepts should be very crystal clear in your mind, right? After that, exception handling, file handling, all of those stuff. Apart from that, you should have a very good understanding about, basic coding in Python. Your logic building should be pretty much clear. Just for an example, if you have to create a basic program to let's take an example. Okay, I'll just just take an example. You go to a restaurant, and what happens nowadays? You have a QR code in front of you, right? You scan the QR code, and you get the menu in front. You choose your items, and the order is placed. You get your bill. The bill asks basically the system asks you to if you want to give a tip for the service or something like that. So you add yes or no, you feed the amount of the tip you want, and you get the total amount of bill. And it is asking you whether you want to pay via cash or card. So it's like an end-to-end application. Trust me, very basic application, very basic program which we can create using pandas, Python. So the concept should be very crystal clear, and you should know basic coding at least. You should know how to write Python code for a small task. Try to practice more and more so that you can, application building is very clear. I'll try to show such a program which I discussed right now after at the end of the session, right, if time permits. After that, in pandas, these are the few important topics, like pandas basically is data manipulation and data analysis library. What do I mean by data manipulation? So whenever we get any raw data, trust me, raw data is always messy, more messy than we can even imagine, right? So we need to manipulate the data. Or to manipulate the data, we need to understand the data. We need to understand the use case. And let's say we have the source, the data, the raw data, and we have the destination, the machine learning model, or the output which we want to create. To reach from source to destination, we have to clean our data. In cleaning, for example, we have to handle missing values, null value, duplicate values. We have to handle data inconsistent formats. For example, somewhere date is given in DD, YY, and MM format. Somewhere the date is given in MM, YY, and DD format. So the format should be consistent, right? So we can read the data using pandas. We can clean the data using pandas, filter the data, group, aggregation, merging and joining, pivot tables, and many more. Right? Pandas is one of the most important libraries while you work with machine learning project or data science project. Right? After that, we have to have good understanding about NumPy. NumPy is nothing but numerical Python, right? To perform all the numerical calculations, mathematical operations on any kind of data set. We should be aware about NumPy. Always remember one thing: in Python, the data types are different. In pandas, there are different data types like data frame and series. In NumPy, we have arrays. So every library has different data types. Then moving on, we should know about Matplotlib and Seaborn. Okay, so before learning these libraries, you should have very good understanding about the graphs and charts and visualization. For example, okay, let's take an example. There can be multiple ways to analyze a single data point. For example, sales per year. So you can visualize it using bar graph, line chart, area chart, or some other types of graphs and charts. But what is the most suitable graph to show that data point? Why I'm discussing this? Because as a data scientist, I have lots of time. I can create charts and graphs to show to my manager, to CMO, to CEO. But the C-level executives, they have very less time. You need to be very efficient, very precise with your data points, with your findings, with your presentation, right? So the graph should be very crystal clear. It should be in a way, it should help the C-level executives to understand the data point in a single click within few seconds. So to show the trends and patterns like of graph, line chart is one of the most suitable graph. Let's say we have 3 to 4 different categories of products. For example, furniture product, electronics products, and so on. And if you want to visualize what percentage of sales is being contributed from different categories of product, so we need to use pie chart. Pie chart will have very good representation. Although we can visualize that data point using bar chart, but pie chart will be more effective. Right? So you need to understand about the different bars and charts, graphs, and how do you create that. I have an example for you in front of you. Let's say a restaurant owner wants to see the peak dining hours. For example, like in 24 hours, what is the peak hour for sales for the at which the customers, the users are visiting the restaurant. So you can have a data point, you can have a list of hours, customers, then you can create a bar chart or maybe a line chart which can show you the trend. Okay, roughly at around 4 to 6 p.m. in the evening, people are ordering the most, coming to the restaurant the most, right? So this is the way how we can use Matplotlib and Seaborn to understand the data points, to present, to see the findings, to see the patterns in the data and observe them and take a data-driven decision. Right? I hope everything is clear till here. Is there any question? Just let us know in the comment section or something. Right? And then moving on, after this, all of these libraries, we should move on to machine learning. And that's where the real game begins. That's where the real picture begins. What is machine learning? Okay, so I always the beginning of machine learning. The idea was that can we train computers? Can we train a machine like we train a human? Let's say when we were kids. So how were we trained? We were seeing some things like, for example, this is a book. We were seeing like this something. This is called a mobile phone. This is called earphones, right? This is called spectacles. So we were seeing some data points, and we were told that this is mobile phone. This is a bottle. This is a earphone. This is a book. This is a mouse. This is laptop. This is something. This is this, and this is that. In a very similar manner, we try to give some data points to the machine and the output to the machine so that it can draw the pattern in itself, in its mind. Right? I hope I'm able to make it very easy for you to understand. In a very similar manner, we want to train the machines. That is why it is called machine learning. Correct? It's a technique where we train the computers so that computer can learn the pattern from the data without explicit programming. Okay, so there is a difference between machine learning and traditional programming. In traditional programming, we are writing some code, do this and do that. But in machine learning, I'm just giving the data to the machine and it is observing in itself. It is trying to learn from the data itself and predict. So these are the two different things. I'm not explicitly programming the machine learning. Correct? So that is how we create machine learning. So there are three major categories of machine learning models. First is supervised machine learning, unsupervised machine learning, and reinforcement learning. Nowadays, reinforcement learning is too popular. Recently, you must have listened about DeepSeek. This is nothing but a very vast application of reinforcement learning. Okay, so what is reinforcement learning? The model learns by trial and error. For example, we as humans, we were trained when we were kids. But now when we grow up, we perform something, we make some mistakes, we encounter some financial loss, time loss or something like that, and we learn. We bounce back, we do something else, we make some mistakes, we learn. So we learn by ourselves, by trial and error method, and that's how life goes on. In a very similar manner, reinforcement learning creates machine learning models which are learned by itself, correct? By the data points, by the error, by the current observations and everything. Then what is supervised and unsupervised machine learning? Supervised machine learning is nothing but when we have labeled data. For example, this is a data and the labeling is mobile phone. This is another data and the label is book. This is another data and the label is earphones. This is another data and the label is bottle, water, right? So when we have labeled data where we have input and the output, then we call it as supervised machine learning. But for an example, someone shows you this and you doesn't tell you what is this. How will you understand? That is nothing but unsupervised machine learning. When the model tries to find the pattern by itself from unlabeled data, that is a very tough task. That is a very tedious task actually. Correct? So there are different kinds of machine learning models like supervised machine learning, where the model learns from the labeled data. Example is spam detection. Okay, so let's say when we go to Gmail, we always see there are some emails which are into spam category. Why? Because someone somewhere has trained some machine learning model that, okay, if an email has this and this keywords, these keywords, mark it as a spam. For example, if the email is talking more about finance, money, submission of the money, or some scheme, Ponzi schemes, or anything else, offers, sales, discounts, something like that, mark it as email spam. So we had the labels along with the inputs. And supervised machine learning, the model finds patterns in unlabeled data. Example, customer segmentation. Let's say you own an e-commerce platform. Let's say you are the founder of Amazon and you have lots and lots of customers across the globe. And now you have to perform some customer segmentation. Like, okay, these are the customers which falls into middle class category. These are the customers which fall into upper middle class category. These are the customers where I have to perform this kind of advertisement. You do not have any labels beside those customers. You have to do it by yourself. You have to train such a machine learning model which can segment the customer based on their behavior itself, like product placement. All of this comes under the category of unsupervised machine learning, right? So these are the some introduction about machine learning. I hope this is clear. And why do we scikit-learn from machine learning? Because as I already said, scikit-learn provides all the necessary tools, technologies, functions, and everything for classification, regression, clustering, model evaluation, and everything. Correct? Now you must be wondering, Akshat, what is classification, regression, and all? Okay, so in supervised machine learning, there are two further categories: classification and regression problems. What is classification problem? Where we need to classify something. For example, email spam detection. So we must have a new email and we have to classify them into two categories, either spam or non-spam. What is regression? Let's say you are building an application, you are building a website, or you are building a machine learning model which predicts the price of a laptop based on their configuration. 4 GB RAM, 16 GB ROM, or 64 GB ROM, and this much screen display, LED screen, 15 inches. This is the keypad, and these are the processor, CPU, and all of those stuff. Based on the configuration, you need to predict price of the laptop. So whenever the output of a machine learning model is somewhat related to numerics or continuous outputs, we can call those algorithms regression algorithms.
Hello.
Classification
Akshay sir, sorry for interrupting you, sir. Can you please check chat box? Behalf of my clients, I raised some questions.
Okay, so for sure. Let me just finish this classification and regression.
Sure, please, sir. Okay,
yeah.
Please do.
So these are the classification algorithms in which we have to classify some output like based on the given input, and regression algorithm which has continuous data. Correct? And let me just quickly see the chats. Like what are the questions? Do I need a strong mathematics or coding background to learn data science? No. Okay, so as per my understanding, mathematics is important, but very hardcore coding is not important, right? Nowadays, since the evolution of generative AI, we can use ChatGPT, we can use lots of internet, and there are lots of material, which are available on the internet. So you can begin your journey, but mathematics is important, right? But coding, you gradually learn with the flow. How can I practice and gain hands-on experiences? Okay, so see, basically, guys, to practice machine learning model, the best platform is Kaggle. Okay, I'll show you one thing. I'll just go to kaggle.com live. Right. So in this Kaggle, we have lots and lots of data set, lots and lots of notebooks. It's a free platform, basically. So you guys can use it for your purpose. Let me just quickly open it. Yeah. So see, in this, in the left pane, you can see the lots of data sets. And let's say you want to eBay stocks to 2025. This is the data set, right? And when you go to the code section, people have created a price prediction, eBay stock price prediction. So people have already given lots and lots of projects, lots and lots of code where you can copy the code. You can learn from the code. You can, do some enhancement in those code to practice, to learn more. After that, the next question I think was, what job roles can I apply after learning data science? Okay, so that's a very interesting question. Based on your skill set, guys, like you can apply for data analyst. Okay, so see, there are different job roles like data analyst, data scientist, machine learning engineer, and then AI engineer, data visualization tools. Like, there are lots of job roles. So if depending upon the different skill sets you have, you can apply for different job roles. For example, if you know Python, SQL, Tableau, Power BI, or all of these, or some of these, you are a very good fit for data analyst role. If you know Python, SQL, and you are willing to learn PySpark and some things related to data engineering, like you're a very good fit for data engineering roles. For data science roles in particular, you need to have very good sense of Python, then machine learning libraries like scikit-learn, TensorFlow, PyTorch, and all of those stuff like deep learning, machine learning, and other skills, right? So based on the different job roles, you have to learn different tools and technologies. But what we are discussing currently will definitely help you to work as a data analyst or as a data scientist. Okay, yeah, right. So like scikit-learn for machine learning is a very good library which we should learn. Like just let us understand, okay, some real world use cases of machine learning. Just for an example, fraud detection in banking. Let's say you are working in any financial industry with any bank or with some fintech company. So fraud detection is a very good use case, right? So obviously we know that in day-to-day
Let's jump
transactions.
into our next question here. Thank you for that.
Right, so solving a real world problem with the data and data science, like for example, fraud detection in banking application. So what happens globally every day, lakhs and crores of transactions occur, right? So then it becomes very important for a bank or for any fintech company to avoid fraudulent transactions, right? So how does that happen? The bank collects a past transaction data. They label the past data, like based on different parameters from source, destination, what kind of applications were used, what were the comments. So they credit history of the sender, receiver, all of those stuff. They gather lots of data. They label the data that this was a fraud transaction, this was a non-fraud transaction. This is a very classic use case of classification algorithms, correct? They collect the data, they label them. Then they train a machine learning model that, okay, in any transaction, if this data point exists, mark it as fraud. If this and this kind of data point exist, mark it as non-fraud, right? So we identify fraudulent and non-fraudulent transaction based on past data using machine learning models. Similarly, spam detection in emails. Another use case is sales prediction. This is a classic use case of regression algorithms, correct? So for example, let's say you are working in any e-commerce platform and Christmas is approaching. So obviously you need to maintain your inventory so that you can deliver the gifts and everything, whatever people orders, timely. What you want to predict the next month of sales, right? So what you will do, you will gather the previous data, load it using pandas, visualize the data using matplotlib, and then create a machine learning model which will understand a pattern from the past data and try to predict, okay, this can be the potential sale in next month or in the next quarter, correct? So this is how, these are the very classic use cases of supervised machine learning, right? So these are all the pretty much topics which I really wanted to cover in a very short span of time. I hope this like all of these in combination gives you a glimpse about data science industry, machine learning, all of those stuff, right? So I hope this helps. And now I'm open to questions, open to all the questions. If anybody has any questions in your mind, like just ask me. I can give you some platforms where we can practice Python. And so is there any question from anybody? I'm happy to answer. Guys, come on. Like, it's very important to ask questions, like whenever we are in such a seating.
Yes, at least you guys acknowledge so that.
Color.
Okay, I think there is no further questions. So like I would like to hand over this all to Vijayji, and yeah.